Okay, today we're going to talk about shapes, and I know you've been talking about shapes probably since, maybe kindergarten or preschool. Um, but what I want to focus on today is not just saying, oh, hey, look, this is a triangle because I know it's a triangle and I've known that for, 10 years or so, but how do I know this is a triangle? Maybe how do I know that this is perhaps an isosceles triangle, a special kind of triangle? Or how do I know that this is a rectangle specifically? Or how do I know that this is a trapezoid specifically? Or maybe even more specifically, an isosceles trapezoid because two sides are the same length. So we're going to start talking about not just saying what a shape is, but proving what a shape is. Sort of like this judge is trying to prove maybe which of these gentlemen did something bad. Um, let's take a quick look at the different types of quadrilaterals. This should be review. Remember, quadrilateral is anything with oopsie daisy, four sides. And so here's just 1, 2, 3, 4. That's just your basic quadrilateral. What I want to introduce is some special symbols. So, for example, if I say on this trapezoid that the top is parallel to the bottom, I can show the parallelness with little arrows. Those show that that line is now parallel to that line. And so there's just our regular trapezoid. But if I want to be more specific in the trapezoid way, well, if the top is parallel to the bottom and the sides are congruent, so just a dash mark, and a dash mark means that those two sides are congruent, then this is an isosceles, I-S-O-S-C-E-L-E-S, isosceles trapezoid. Isosceles meaning two sides are equal or congruent. So far we have the little arrows mean that something is parallel, and the little dash marks mean that something is congruent or equal. So here's just a regular four-sided, nothing special about that, but on this one here we have this is parallel to this side is parallel to this side, and in addition, that's equal to that, and that is equal to that. So once we start to have multiple sets of parallel or congruent sides, we start to use multiple dashes or arrows. This, hopefully you're saying to yourself, is a parallelogram. Parallelogram. And then we have four special kind of parallelograms. Underneath that we have our rectangle, which has, of course, opposite sides parallel and congruent, but also four right angles. Since we already said it's a parallelogram, I'm not going to mark the parallel parts, okay? The little corner dashes, right angles, we've talked about that. So this is our rectangle. We have our square, which has four congruent sides, four right angles, and of course opposite sides are parallel. And we have our rhombus, which has our four congruent sides but no right angles. But still, since these are all parallelograms, opposite sides are all parallel and congruent. And then, of course, we even made it look like a kite. This is our kite over here. In our kite, the adjacent sides are congruent. So the two short sides touching each other are congruent, and then the two long sides down here are congruent. So there's hopefully a quick review of quadrilateral. We call it a hierarchy because sort of like hierarchies in the days of kings and queens, we have people on top and things get more specialized and so forth. When we talk about types of triangles, we have ways to label them according to their angles, not angels, and ways to label them according to their sides. So if it's acute, then it has all the angles are less than 90 degrees. If it's a right triangle, it has one angle equal to 90 degrees. An obtuse triangle has one angle greater than 90 degrees. When we talk about the sides, we mentioned this when we had the trapezoids, but an isosceles means two sides are congruent, or in this case, equal. Okay, scalene means no sides congruent. And equilateral means all three sides congruent. The symbol for congruent, by the way, besides actually marking on here, so we might say that this side length is equal to this side length. If I knew that maybe this was triangle A, B, C, I might say that side length A to C is congruent to side length A to B. Okay, so we say the side lengths, we show it's a length by putting a little line over the top. It's a segment. And the congruent symbol is the equal sign with a squiggle on top. So what we do with triangles typically is we might say this is a right triangle because it has a 90 degrees, which you can't see because I'm doing in blue. Oh my goodness. This is a right triangle. And it looks like this side length is equal to this side length, so we call this a right isosceles triangle. So we start to use a label about the angles and a label about the sides together. Okay, now that we had a quick review of quadrilaterals and triangles, we want to start to use this information to prove what type of a shape is. So we're going to go back to our coordinate grid because we've been working with coordinate geometry. And I'm going to put these points on. I have negative 9, 0 is Z. Negative 4, 7 is A. And 3, 2 is C. And if I can just quickly connect the dots here. Now, what we want to think about is, okay, what shape is this? Well, clearly it's a triangle. And you've been saying things like that since kindergarten. But we want to know what kind of a triangle. Is this a special kind of triangle? So is this special? Well, one of the things you might want to do is see, oh, this kind of looks like a right angle, but I don't know for certain if it's a right angle without checking the slopes, because if this is a right angle, then the slope from Z to A should be perpendicular to A to C, the slope from A to C. So to find slopes, remember we can do rise over run, so I'm going to just count. Remember we're going by 2, so that's 1, 2, 3, 4, 5, 6, 7. I went up 7, and I'm going 1, 2, 3, 4, 5. So I went up 7 and over 5. And if I go from A to C, I'm going to go down 1, 2, 3, 4, 5. So I went down 5, and I'm going 1, 2, 3, 4, 5, 6, 7. Negative 5 over 7. It appears, since the slope from Z to A is 7 over 5, that is the opposite reciprocal from A to C, which is negative 5 over 7. So I have proven, so I might say that because ZA and AC have slopes that are opposite reciprocals, then triangle ZAC is a right triangle. because if this line and this line are opposite reciprocals, then yes, now I can say that this is a right triangle. I have used some mathematics to prove this. I haven't just said because it looks like it. Okay, we're going to prove it. Let's take a look at another example. Here we have CLAY. Since I have 4 points, I'm assuming this is going to be a quadrilateral, so I have C is -2, -3, C. L is 3, 2. A is 10, 1. And Y is 5, -4. 5, -4. And let me just connect the dots here. C to L, L to A, A to Y, Y to C. What does this look like? What does this look like? Well, to me, it looks like a parallelogram. And so the first thing I want to do is find the slopes of the lines. And if you don't mind, I'll just do rise over run right here on the graph again. So from C to L, I'm going 1, 2, 3, 4, 5, up 5, 1, 2, 3, 4, 5 over 5. Looks like the slope's going to be 1. This one I'm going down just 1. 1, 2, 3, 4, 5, down 1. 1, 2, 3, 4, 5, 6, 7. So it looks like down 1 and over 7. From Y to A, I'm going up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, I'm going up 5 over 5 again. So far this line is going to be parallel to this line. And 1, 1, 2, 3, 4, 5, 6, 7, down 1 and over 7 again. So now this line is parallel to this line. So yes, so far we do have a parallelogram. The other thing I'm seeing though is these lines look awfully similar to the same length. So far I know that the opposite sides are parallel. I want to check lengths, because if the lengths are also the same, then we have a rhombus here. So the lengths are also known as the distances, right? So if I want to go from C to L to find the distance, I'm going to take the square root and I'm going to do, let's see, C to L, so 3 minus a -2 squared plus 2 minus -3 squared. Well, this is going to become the square root. That's going to become 5 squared plus 5 squared, which is going to become 25 plus 25, which becomes the square root of 50, which is about 7.07. I did that out earlier. Well, so that's C to L. Now if I do, let's say, L to A, square root, we're going to do 10 minus 3 squared plus 1 minus 2 squared. That becomes 7 squared plus -1 squared, which becomes 49 plus 1. This is also the square root of 50, which we know is 7.07 from up above. I'm going to have to extend the page here. I hope that's okay. And then let's do A to Y, because A to Y is square root. We're going to do 5 minus 10 squared plus -4 minus 1 squared, which becomes 5 squared plus -5 squared, which we know is 25 plus 25, also square root of 50, also 7.07. Very interesting. What do you think is going to happen when we do C to Y? Well, C to Y is going to be 5 minus negative 2 squared plus negative 4 plus 3 squared, which we know becomes, that's going to become 7 squared plus negative 1 squared. This should be looking familiar because now we have 49 again plus 1, which is the square root of 50. Sorry, this is a mess over here. And 7.07. So what we need to say now is CLAY is a rhombus because all 4 sides are congruent and opposite sides are parallel. Exclamation point. Yes, you have to do all this math out. Yes, you have to show all your work. That's part of using the mathematics to prove that CLAY is a trapezoid. Excuse me, a rhombus. One more example. This is an example I wanted to show you. It's in your X and Y are in a matrix, but that just means that L is the X is negative 2 and the Y is 2. And E, your X is negative 3 and your Y is 6. And X, your X is 1 and your Y is 9. And I, your X is 6 and your Y is 8. You don't have to rewrite them like this. I just wanted to show you that sometimes it's more efficient to put your data, your coordinate points in this matrix form. So if L is negative 2, 2, here's L. E is negative 3, 6. X is 1, 9. X. And I is 6, 8. And draw the lines. Whoops. Don't need that one. LEXI. Looks like a trapezoid. How are we going to know if this is definitely a trapezoid? We want to know, is this line here parallel to this line? Well, again, to find if they're parallel, we're going to use slopes. I'm going to count up and over. So I'm going 1, 2, 3, 1, 2, 3, 4. It looks like I'm going up 3 and over 4. And here I'm going 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 6 over 8 is certainly reduced to 3 over 4, so we can say LEXI is a trapezoid because one set of opposite sides are parallel. This side length is parallel to this side. So, make sure that you are not just saying what a shape is based on how it looks, that you are using mathematics. Use mathematics to prove what type of a shape something is. That's it. Have a great day.